Hey, welcome back. In today's video, we are going to taking a look at how we can create arrays in the Ruby C extension. So to start off, we are going to launch our terminal. Maybe zoom it in a little bit so that you can see clearly, and create a new directory called abcd. And cd into abcd, and then create our xtconvert.rb file. We are going to require mkmf, and then we are going to create makefile called, let's call it fiv, because we are going to finish off the section with a Fibonacci sequence. Let's call it fiv now. And then we are going to create a C file called fiv.c. It doesn't matter, as you have seen in the previous video. You can call it anything you want. But to make things consistent, we are going to call this fiv.c and include ruby.h. And then define our function with void init fib. And let's create one array. To create one array, we have to do value a equals to, or maybe anything, abcd equals to rb array new. And to see that in action, we can define a global variable with rb gv set and set $a to abcd. And let Ruby know that it's a global variable. If we compile and run our code, to compile, we have to run ruby xtconvert.rb & make, and to require our code ruby -r, and we are going to have fib.so, and then we are going to execute $a. We need the single quotes here, otherwise it's a bash variable. So if I run this, we don't have a, we have abcd. Sorry for that. If I again compile and run our code, we get an empty array, as you can see here. So we can set various items to the array with this syntax: rb array new from args, and give it item numbers. So if I do 1 and do into fix, maybe 500 or 5000, and if I compile and run this code, you will get an array with one element. But if you want 2 elements, you can do into fix, again say 1000 for example, 100 for example. And we cannot do that because we have 1 here, we have to do 2. And if I compile and run our code, we get 5100. So if I again do rb str new cstr and do hello, and then maybe q true, I don't know. So if we increment it 3, we will get 3 items. But that's wasteful, so we don't want to create extra items and do not require them, right? So that's how we can create arrays. We can also push items to the array with another function. So let's create one empty array, rb array new, and then to push items, we can of course call rb func call v or rb func call, and then give abcd, then run rb intern shovel operator, or maybe push, and then give one argument and maybe into fix 5. But that's not what we want. So if I run this code, as you can see, we have 5 here. This is not what we are going to do because we are calling various functions here. We are calling rb func call, then we are calling rb intern here, and we are also calling into fix here. So we don't want that. We can just use rb array push and give the array abcd. We also need the into fix because we need ruby values, right? So if we do 50, it is going to push 50 to the array. And if I maybe do, we cannot push a number of items here like this. If I run this, you probably get error. And as you can see, we have too many arguments. We don't want that. We have to repeat ourselves. By repeating ourselves, I mean we have to copy and paste this maybe 3 times to get 3 items here, which is not really fast in many cases. And you want to do RBRNU 4 and maybe create items here. You don't want to call 3 functions to slow down your code. So we can do this q true and maybe another array, maybe RBRNU from args, maybe 1, and let's push another array just for fun. So if I compile and run this code, we have errors because too many arguments to function. Okay, we don't want this because, yeah, it doesn't take any arguments. So if I compile and run, you get an array with 50 true and then another array, nested array, with another array. So yeah, it's complicated and it's a tongue twister, but yeah, you can do that, which is completely fine. So now let's create our good old Fibonacci sequence, shall we? To do that, let's create another function called maybe fib, and then we are going to accept arguments, right? We have to do that, value obj, and then unsigned long. Let's define some variables that we need. A equals to 0, b equals to maybe 1, and we also need I equals to 0 for the counter. And we are going to convert a range that many times we will loop over. So we are going to convert range, we are going to assign range to num2 unsigned long because we have unsigned long here, and then the obj. So we have these variables here, and now we have to create one while loop. So we are going to do while I++ less than maybe range. We have C number here, so we can do I++ less than range, and do we are also going to need a temporary variable. We can declare that with maybe temp, because everything is unsigned long here, so I'm not going to risk and make temp another maybe integer, so we will have overflows. So everything is unsigned long, and we are going to assign temp to A and B equals to, we are going to assign temp to B and B equals to A plus B, and then A equals to temp. That's how we can swap variables in C, but there are other ways like XOR and ampersand like short circuit evaluation and stuff. You can do one line swap. That's fancy, but that's slow. Anyway, we are going to get some Fibonacci sequence here. What we are doing here is we are getting B equals to 1 and storing that to temp, and we are changing B equals to A plus B. In our case, it is 0 plus 1. And then we have the temporary variable. So we are going from A equals to 1 to B equals to 1. And then we are going to add A to 1 and B to 2. Then we are incrementing A and B and changing like that. So it always moves like a Fibonacci sequence. If you Google for Fibonacci sequence, I should have shown that before, but I think you know Fibonacci sequence. We have this series 0, 1, 1, 2, 3, 5, 8. We are going to assign A to 0 and 1, and then we are moving A equals to 1 and B to 1, and then A to 1 and B to 2, and then A to 2 and B to 3, and so on and so forth for n times. We have this, and we are going to push the items to the arrays. We don't have any array here, so we have to declare that value ARY, and then push A, but we have to convert it to unsigned long. Now we can return the array safely because we have Ruby numbers. Now we want to create one method on integers. to create a method on integers, we have to do value, maybe call it integer, with underscore. I prefer this because if we have any variable called integer, so I don't override that, but I can guarantee there's no variable with the underscore. So we have value integer equals to rb, define class as you have seen in the previous video, and call integer. But the superclass is different, so we have to do rb c numeric. In the previous video we had rbc object because string inherits from object. So if I open irb here and run string.ancestors, you can see that it actually inherits from object. So you can do rbc comparable, maybe, I don't know. So you must make sure that it is a class. So in our case numeric is a class. If numeric were a module, we had to do m numeric, but numeric is class, so c numeric, and then we have the integer class here, so we can patch it. To patch it and define a method, we can do rb define method and integer, and then the Fibonacci, which we'll call fiv, and then it takes 0 arguments. We are working on self, so we don't need multiple arguments here, so we have 0 argument. And if I compile and run our code, we have aborted core dumped. Maybe we did something wrong. Okay, so actually we haven't defined the array here, so we have to do rb array new, of course. This is very stupid. rb array new, and we have an array here, so we can compile and run it. We get 1 1 2 3 5 here. So as you can see here, it is 0 1 1 2 3 5. We need the 0 in front. We can edit that and rb array new from args and do 1 into fix 0. And if we run compile and run our code, we get 0 0 1 2 3 5 like this. So we can also increase the 5 to 10 maybe and get 10 sequence. So we have 21, 34, and maybe 55 later on. Yeah, so we have 55. And then we have to maybe, we can do 15 here. We can do 30. And you see that we are adding this with this and get even bigger number. So if I do 31, we get this behemoth number. So if I do 32, you get this even bigger number, right? So if we do maybe 40, you can see we have very, very large numbers here. If I do maybe 60 or maybe 100, you can see that we have maybe integer overflow here. We cannot represent such big numbers. We can conquer this problem with the big number that Ruby already has. To do that, let's again edit the fiv.c file, create one method called maybe big fiv. So to do that, we will do value big fiv, what a tongue twister, and value obj. This is very important. And then we are going to define our unsigned long range, because I don't expect a very big number to be the range. For example, you don't want to calculate maybe 1 quadrillion or maybe octillion or nonillion digits of Fibonacci, right? And that will take maybe petabyte or maybe even yottabytes of RAM. So we are going to define unsigned long range because that will be faster, as you will see as I code. And then we have range equals to, let's convert it here. And I for the counter. And then we are going to create the big numbers here. Value a equals to, as we did before, we have value a, b, and of course I. We have defined this in C, but in case of A and B, we are going to define that, and also we need the temp. We are going to define that as value. So value A equals to into fix 0, value B equals to into fix 1, and temp, and keep that empty. And then we are going to define our array. Value array equals to rb new array from args, and give it one arg as into fix 0. And then we are going to continue the loop while I++ less than range, and that's where it gets faster. So if you want to do that in Ruby, for example, you have the each loop and stuff. So if you do that, or maybe you can check if some number is less than some number with maybe rb func call v or rb func call, and check it with arguments and compare the numbers. That will be very slow. You will have a lot of method calls. But for now, we can do this. I++ less than range. We are going to store temp as a, because temp is a value and a is also value. We don't have to convert anything. We can do b equals to a plus b, but we cannot do that. We have to do rb func call, and then a and rb intern plus, and then it takes one argument and add with b. So we are assigning b to this a plus b, and also assign a equals to temp, because b is overrid and we cannot, oh okay, we need b here. So b is overrid and we cannot assign it to b, so we have to keep it in the temp. And then rb array push, same thing, but this time we don't need to convert anything. We can just go with a. Also we need the array name, and that's it. Now we need to return the array. And let's define another function or method, call it bigfib. So if I call bigfib, it calls this function bigfib in C and does this stuff. As you can see, we have rb intern inside a loop, and that will actually loop over again and again and create one new variable which is not really memory efficient. So we can do this value plus equals to rb intern plus, and that's it. So we have to call this plus. We can also define a constant, but make sure that it is not garbage collected. In this function it will not be garbage collected, but if you define the constant here like this, so if you do constant plus equals to rb intern, it will be bad. You can also do this hash define maybe plus to rb intern plus, which is the same thing as doing this here, as defining that here, but which is really slow, so we don't want to do this either. Everything looks good, and let's time to compile and the moment of truth. As you can see, we have errors because b undeclared. Okay, so I have this error. Yeah, okay. Now we can compile and run our code. rb new array. Okay, rb array new. Now this is the old Fibonacci, which is in pure C, but if we do bigfib, you can see the numbers are very, very big, and surely it will overflow. If I do maybe 10 series, you can see that we have the same number, and if I run maybe fib here again, you can see it is exactly same. But if I do bigfib and give it numbers like maybe 1000, You can see these numbers are so big. These are big nums. And we have a screen filled of numbers. By no means we can run this in C. We don't have any crashes because it don't crash. But if we do this big fib and give it some numbers like this big, you can see that it is big num to big to convert into unsigned long long, because we have this function here, right? We have this here. So we cannot convert a very big number to unsigned long long. So again, if we reduce that to maybe this, so as you can see, it increases my memory usage. I have to enable the swap again. And if I run this, it uses a lot of memory, right? So we don't want that. So anyway, that's how you can create arrays in Ruby C extension. And if I again nano it, you can see that it's very, very simple. We can push item, we can have a number of arguments here. So to know more about this, you can use this guide written by Silver Hammarba. I don't know them, but there are a lot of things you can learn from here. So we have maybe RB rescue, protect and stuff. We have a lot of interesting stuff going on in here. They also showed how you can rescue errors, how you can define global variables, class instant variables and stuff. We also have super here. So if I search for maybe C object, okay, they do have a very nice guide here. So for example, C object, yep. So most of the standard Ruby constant have value, define them in API, so you don't need to call API access. So you don't need to have API access to call them. Modules are prefixed with RB M, example RB M kernel, as you see in my example. So we had RBC object and RBC numeric because that was a class and not a module, but kernel is a module. So when you need to patch the kernel module, you have to run RB M kernel, or maybe the superclass. If the superclass is a module, you have to run RB whatever the module name is. So that's it for today's video. Hope you find this video interesting. If so, please press the like button and hit subscribe. If you don't like this video, please leave a constructive criticism and dislike this video. That will also motivate me to improve my channel and these free contents. I do thank you for watching and hope that you have a great day.